Hey guys, Mr. Backerberg here. In this video, we're going to look at evaluating limits using rationalizing. So taking a look at this first example, we want to find the limit of the square root of x plus 1 minus 1, all being divided by x. We want to do that limit as x is approaching 0. If I tried to direct substitute the 0 in for those x's, we would get 0 over 0, which is our indeterminate form. So we're unable to determine this limit based on the way it's written right now. So we need some sort of technique to help us adjust how this limit is written to make it more solvable or easier to work with. So rationalizing is something that we use to help us get rid of or move a square root. So if I look at that numerator where we've got the square root of x plus 1 minus 1, what we're actually going to do is take the conjugate of that. So the conjugate of that, it's going to leave the square root the same, so that's going to stay as the square root of x plus 1. But on the back end where it says minus 1, well, the conjugate is going to say plus 1. And we're going to multiply by that on the top. But whatever we do to the top of the fraction, we also have to do to the bottom of the fraction. So we're going to multiply by that exact same conjugate in the denominator as well. Now, algebraically, some nice things are going to happen using this multiplication by the conjugate. If we think about foiling out the stuff that we have on top, the first thing that we would have to do is take that square root times the square root. And the nice thing about that is when you take a square root and multiply it by itself, the answer you get is just the stuff that's underneath the square root. So we just get the x plus 1. Now, if I take that square root times the positive 1 on the back end, I would get plus the square root of x plus 1. But then if I take this negative 1 times this square root, I'm going to get minus that same exact square root. So again, algebraically, some nice things are happening because we have this plus square root and this minus square root that happen to be exactly the same. So in just a little bit, those are going to cancel each other out. But I still need to take the negative 1 times this positive 1 on the back end. And negative 1 times positive 1 is negative 1. On bottom, I'm not going to worry about trying to distribute the x. I'm just going to leave it written as x times this conjugate for right now. And I'm going to hope that some things cancel out in just a little bit. So on top, I mentioned that we have this positive square root and this negative square root. And since those are exact opposites of each other, those are going to cancel out. But then I also notice inside of this set of parentheses in the front, I have this plus 1. And on the back end, I have this minus 1. So those cancel each other out as well. So now we're down to x over x times the square root of x plus 1 plus 1. And then what I notice with this is that those x's are going to cancel each other out. So we've got just 1 over the square root of x plus 1 plus 1. So now I'm going to try to take the limit of that. So the limit of 1 over the square root of x plus 1 plus 1, and we're doing that limit as x approaches 0. So now if I direct substitute that 0 in for the x, well, 0 plus 1 is just 1. The square root of 1 is 1, and 1 plus 1 is 2. So it looks like I get the limit to be 1/2. Checking out this example, we've got the limit of 1 minus the square root of 1 minus x all over x, and we're doing that limit as x approaches 0. If we tried to direct substitute that 0 in, we would get our indeterminate form. So we're going to need to adjust how this limit looks. So I'm thinking we'll use that rationalizing and we'll use the conjugate. So I look at the numerator where that square root is. The conjugate of that would be 1 plus that square root of 1 minus x. And whatever I multiply the top by, I also have to multiply the bottom by. Now on top, if I think about foiling this out, 1 times 1 is just 1. 1 times that positive square root gives me plus the square root of 1 minus x. If I do that negative square root times 1, then I get a negative square root of 1 minus x. And then if I take a negative square root times this positive square root, well, anytime you multiply a positive times a negative together, you're going to get a negative answer. But then, because we're multiplying a square root by its exact self, the answer we get is just the stuff underneath. So just the 1 minus x. Now on bottom, I'm not going to worry about trying to distribute that x. I'm just going to write it as x times 1 plus that square root of 1 minus x. I'm going to look at the top because I'm hoping for some things to cancel out. I see in the middle a positive square root and a negative square root that are exact opposites of each other. So I'm going to cancel those out. I'm actually going to take this negative on the back end and distribute that in real quick. So I get 1 minus 1 plus x all over x times 1 plus the square root of 1 minus x. On top, I have a positive 1 and a negative 1 that are going to cancel each other out. So now I've got x over x times 1 plus the square root of 1 minus x. I notice that with those x's, those are going to cancel each other out. So now I'm down to just 1 over 1 plus the square root of 1 minus x. So now I'm going to try to do the limit of that. So we're doing the limit as x is approaching 0. If I direct substitute that 0 in, well, underneath the radical, 1 minus 0 is 1. The square root of 1 is 1, and then 1 plus 1 is 2. So it looks like I'm getting a limit of 1/2. That's going to be it for this video. Thanks for watching.